flows through water contained in an insulating tube 10 centimeters long and 5 centimeters in diameter. When a 100 volts potential difference is applied across the ends of the tube using electrodes inserted at either end. The condition is ignore any complications from the metal electrode water contact and do the calculation using the 3 entries in table 16.1 for different purities of water. And table 16.1 is just above this problem. It has 3 kinds of water. One is a distilled water. So the resistivity is 2 multiplied 10 to the 5th. And the fresh water, 5 times 10 to the 2nd. And the sea water, 0.3 only. Okay, the truth is, in this table, the larger the number is, the worse the conductor is. Okay, the small number will make a good conductor. And I don't want to do 3 of them. I just pick up fresh water. We do the calculation on fresh water only. For the other kinds of water, so it's the same calculation but different number. Okay? So it's example number 1. It's 16.1 on page 404. And here I just do fresh. And for fresh water, the resistivity is, resistivity is 5 times 10 to the 2nd with the unit of ohm times meters. That one is assumed to be the given condition. And you have a tube. No matter the tube is a straight one or a curved one, it doesn't really matter to us. Okay, something like that. The total length is 10 centimeters. And the diameter is given, which is 5 centimeters. And the potential difference between the 2 ends, 100 volts. Let's write them down. The L is 10 centimeters. Therefore, you need to make a change. You cannot use centimeter. You have to convert it into meters. And the diameter is 5. Therefore, what's the radius? 10. 10?
And diameter is 5, radius is half.
Therefore, it's half.
2.5.
Centimeter, you have to change it back to meters. 0.025 in meters. Okay? And the total voltage, V, is given as 100 volts. Anything else? No? That's all. You have 4 given numbers. You need to find how much electric current flows through the water contained in the insulating tube, which means you need to calculate this. What's the current inside the tube? Yeah, think about it. Based on the given condition, how can we find the current inside the tube?
Total change over time using Ohm's law.
Obviously, the time is not given here, right?
So just use Ohm's law.
Ohm's law, okay. This one doesn't work. No T here. Therefore, probably this one is true. I equals V over R. V is given already. Therefore, you just need to find what? The R. What's the shape of the tube?
Cylinder.
Cylinder. Therefore, there is a formula right here for cylinder. The resistance equals rho times L over A. Rho is given already. the L is given 10 centimeters. A is the cross-sectional area. It's not given, but the radius is given, right? If you know radius, you can calculate the area. All right, therefore, it's an easy problem. I write down the solution over here. Therefore, we calculate resistance first. It equals rho times L over A. Just keep going one more step. You know L, but you don't know A. How to express A if the R is given? You know radius, how to calculate area?
Pi r squared.
Pi r squared.
Obviously, it's pi r squared. You just replace A by pi r squared. Therefore, you are ready. So therefore, just put in numbers. It's 5 times 10 to the second for rho. Then multiply L is 0.1 here. And pi is 3.14. Then times r squared. 0.025 squared. Therefore, you have a solution. But unfortunately, my solution is different from the book for fresh water. I trust myself. It's 2.55 times 10 to the 4th ohms. If I made a mistake, tell me, okay?
No, I think you did this the same, only they multiply their answer times 5 times 10 to the,
Really?
yeah, square.
Okay, I'm happy
So it's
about
same.
that. All right, if you know R, you are ready to calculate the current. Ohm's law, I equals V over R. We know everything now. Therefore, direct calculation. So V is 100 volts, and R we just calculated, 2.55 times 10 to the 4th. Well, you got a current directly. How about that's a very small current? It's 3.92 times 10 to the negative 3 in the unit of amps. And for seawater, distilled water, the only change is this number is different, right? The other thing remains exactly the same. We don't have to do it 3 times, just 1 time. Enough. Okay, that's the first example. The second example is additional one. All right, so you can take a note for the problem. Example 2. A copper wire has a diameter.
Can I ask you a quick question?
Yeah.
You know how you're going to change the homework, and we're going to have the homework at the end of the chapter? Is the test questions going to be a lot more difficult than the homework questions?
No.
Oh.
Homework is much harder than the exam problems.
Okay, yeah, let's do that.
If I pick up the hardest problem in the exam, everybody will be in the trouble.
Okay, hey, I just want to make sure.
If the difficulty index of your homework is 10, for example, your exam problem